All right, number one, we have to distribute 1/4 to the 12x and the negative 8. A fourth of 12 is 3x. A fourth of 8 is 2, so I get minus 2. And then I have to distribute the 2 to the 6x and the 1, so plus 12x plus 2. Now combine like terms, 3x and 12x make 15x. Negative 2 plus 2 is 0, so we end up with just 15x. Number 2, I've got to plug in. So a negative absolute value of a, which is negative 2, minus 3 times b, which is 6. So inside of that absolute value, we've got to do some evaluating. So keep the negative outside, absolute value of negative 2, and then I take minus 3 times 6 being 18. I'm going to move up here, keep the negative out front of the absolute value. Negative 2 minus 18 is negative 20, so I have absolute value of negative 20. The absolute value of negative 20 is 20. I still have the negative sign out front, but the absolute value of negative 20 is 20, so I end up with just negative 20. Number 4, plug in 2 times b, which is 1.5, times, I'm going to use brackets here, 4 times a, which is 5, minus c squared, so 11 squared. The 11 is squared, not the negative. There's not parentheses around negative c, so be careful when we square. I'll square right now. Let's go ahead and do 4 times 5 as well. Minus, and 11 squared is 121. So it's not it's not plus 121 because the negative wasn't squared. Okay, move on up here. 2 times 1.5 times, I'll go ahead and just call them parentheses now, 20 minus 121 is negative 101. Multiply from left to right, 2 times 1.5 is 3. 3 times negative 1.1 is negative 303. Number 4, I want to subtract this 5. 18 equals negative 2/3 m. Now to get rid of that coefficient, which is a fraction, I would want to multiply by its reciprocal. So negative 3 over 2 to both the left and the right. You might want to think of that 18 as 18 over 1. And then I can simplify the 2 and the 18 because they're both divisible by 2. So I end up with negative 3 times 9, so it's negative 27 equals m. Number 5, got to distribute 8x minus 36 equals 3x plus 4. I'm going to subtract the 3x over, giving me 5x. I'll add 36 over to the 4 to get 40. Divide by 5 to get x equals 8. Number 6, solve it for x. So first thing I need to do, because x is in the numerator, I need to get rid of that denominator. So I'm going to multiply both sides by 3. So 3 times y is 3y. Here the 3's will cancel, leaving me with just x minus 5. And now to solve that for x, I would add 5 to both sides. It's not a like term with 3y, so I just have 3y plus 5 is equal to the x. Or x equals 3y plus 5. Number 7, I have to isolate this absolute value. They're not parentheses, I can't distribute the 3. I have to divide by the 3, both sides. So I get absolute value of x minus 5 is equal to 4. At this point, I have to get rid of the absolute value by creating two equations. What two numbers have an absolute value of 4? Well, that's 4 and it's negative 4. So x minus 5 has to be one of those two things. It could be negative 4, it could be positive 4. Set up both equations, because this number could be either one of those. So solve them both, add 5, I get x equals 1. Add 5 over here, I get x equals 9. Solve and check. On number 8, the absolute value is already isolated, so set up the two equations. 3x minus 1, what does it equal? Well, can equal 2x plus 11. Notice that's an algebraic expression. So I don't really know if 2x plus 11 is positive or negative, which means I'm going to have to check my solutions. That's why the instructions tell you to check. So there's one of the equations. And then 3x minus 1 could also equal the opposite of 2x plus 11. The opposite of 2x plus 11 is negative 2x minus 11. You have to change both signs. So we're going to solve both equations. So on the first one, I'll subtract 2x from both sides, giving me x. Add 1 to get 12. X equals 12. I'll check them in a minute. Let me find the other one first. Add 2x, giving me 5x. Add 1 to get negative 10. Divide by 5. X is negative 2. All right, to check 12, plug it in the left side. 3 times 12 is 36, minus 1 is 35. So I have absolute value of 35 on the left side, equals, on the right side, 2 times 12 is 24, plus 11 is 35. Okay, does the absolute value of 35 equal 35? Yes, it does. So 12 is the solution. Let's check negative 2. So absolute value, 3 times negative 2 is negative 6, minus 1 is negative 7. So absolute value of negative 7 equals, then plug it in over here, 2 times negative 2 is negative 4. Negative 4 plus 11 is 7. Does the absolute value of negative 7 equal 7? Yes, it does. So that's a solution also. There were no extraneous solutions. They both work. That's possible, but it's also possible that you plug them in and they don't work. So you do have to check. And if they didn't work, you would just, if one of them didn't work, you would just cross it out. All right, number 9, write an algebraic expression. So 5 times the difference of 7 in a number. So I'm going to do 5 times parentheses. Difference means subtraction of 7 in a number. So 7 and difference, so subtraction, a number. So x or n or whatever letter you want to use. There we go. 5 times 7 minus x. Number 10, give an example and a non-example of something in each group. So natural numbers. Natural numbers are the positive integers starting at 1. 1, 2, 3, 4, 5. So give an example of one of them. Could be 1, 2, you only have to give one of them. What's something that's not a natural number? We could say 0, because it doesn't include 0. We could also say negatives. We could say a decimal or a fraction. Just give a number. There's an infinite number of them. Whole numbers. Whole numbers are positive integers, but also include 0. So maybe I include 0 for my example. Don't have to. You could give 1, 2, 3, 4, etc. What about a non-example? Maybe a negative, negative 3, or maybe a decimal or a fraction. An integer. Well, integers can also be negative as well as positive, so maybe I would go with like negative 3, just randomly. What's something that's not an integer? Well, a decimal or a fraction. Maybe I would go with 1/2. Rational numbers. Rational numbers are numbers that can be written as fractions, or if they're decimals, they terminate or repeat. I'll just use a fraction. I'll do like 3/4. That's an example of a rational number. Something that's not irrational would be like a square root that doesn't simplify to an integer or a rational number. Pi would be a non-example, or a decimal that goes on forever and doesn't repeat. I'm going to use like square root of 2. I wouldn't want to use like square root of 4, because square root of 4 is just 2. It would be rational rather. What about irrational? I could use another square root. I could also use like pi. Pi is irrational, so that's an example. Something that's not irrational is something that is rational. So, 1/2 or 2 or 5, something like that. A real number. Well, all of the examples I just used, including all the non-examples, all of those are real numbers. You could list anything, as long as it's not an imaginary number. And if you don't know what imaginary numbers are, then don't worry about it. So I'll do 6. I crossed out non-examples just because we haven't talked about imaginary numbers yet, but imaginary numbers are non-examples, and that would be like an I. So if you know what that is, you could put that for non-example, but we haven't talked about it, so I wasn't concerned about it. Number 11, the length of a rectangular garden is 7 feet longer than its width. So the width is the smaller one. So if the width is smaller, I'm going to use a W for its variable. I like to give a variable, assign a letter to the shorter distance, and then for the length, it tells us the length is 7 more than that. So I would use W plus 7 for my length. talking about a rectangle, and it's a perimeter. So, perimeter, you have two widths. So 2 times W plus 2 times the length. So 2 times W plus 7. That equals the perimeter, and we know the perimeter is 38. So I have some distributing to do here to simplify this. 2W plus 14. Combine like terms, I'm going to move over here. 2W plus 2W is 4W. So 4W plus 14 equals 38. 4W equals 24. So W equals 6. So we have to find the width and the length. So the width was 6 feet, meaning the length was 13 feet. All right, then now inequalities, solve and graph. Okay, so let's add 14 to both sides. Oops, I don't know why I wrote equals. It should be a less than. So 10t is less than 20. Divide by 10. We get t is less than 2. To graph that on a number line, I'm going to put 2 in the middle of my number line. It's an open interval. It's less than, so we go to the left. Number 13. A couple ways you could do this. You could distribute. You could subtract 3, divide by -3. I think that's probably the easier way, but I'm guessing it's more common to distribute, so I'm going to show you that method. Combine like terms. So -12W plus 6 is greater than or equal to 18. Subtract the 6. So -12W is greater than or equal to 12. I have to divide by a -12 now. And anytime I divide by a negative or multiply by a negative, my inequality sign switches. It flips. So instead of greater than or equal to, I now have less than or equal to. And 12 divided by -12 is -1. So I get W is less than or equal to -1. So for number line, put -1 in the middle. Close circle this time because it's equal to, and it's less than, so I go to the left once again. Number 14, I'm going to add 17 to all three parts. 12 is less than 6, n is less than 30. Divide by 6, 2 is less than n is less than 5. So that's solved. Now for the graph, smaller number is 2, it goes towards the left, 5 goes towards the right. They're both open intervals, and we want to shade between them. This is an and inequality. We look at the overlap, we shade in between. 15. Notice, first of all, they have two different variables, x and v. That shouldn't be the case. That wasn't intentional. Let's make them both the same. I'm going to change the v to an x. Okay? Solve each inequality independent of the other. So subtract 6 from -22, we get -28. Divide by 7. X is greater than or equal to -4. Or, and then I work on the other one, subtract 11 from 19, we get 8. Divide by -1, so my inequality sign will switch. So we get x is less than or equal to -8. So this is an or inequality. I have it solved. Now I need to graph it. Make sure the smaller number goes towards the left. That's the -8. -4 is larger, so it goes towards the right. So -8 looks like a closed interval. We want to be less than -8, so that's to the left of -8. Or -4, a closed interval, it's greater than, so we go to the right of -4. All right, number 16, absolute value of x minus 2 is greater than 4. Absolute value in an inequality, you got to be careful. These are going to turn into ands or ors. The distance from 0 is more than 4 units away. And so we call this an or. Remember, greater, an absolute value that's greater. It's not true if there's no absolute value, but if there's an absolute value and it's greater, it's going to be an or. So what's true? Well, this expression, the x minus 2, could be greater than 4, like it says. That's one of them. Or, not only could it be more than positive 4, it could be less than negative 4. If it's to the left of negative 4, that's more than 4 units away from 0 also. So I have to consider both of those options. Solve them both. Add 2 to get x is less than 6, or greater than 6 rather. Or, add 2 over here, we get x is less than negative 2. To graph, negative 2 towards the left, 6 towards the right. Open interval on both of them. Greater than 6, so go to the right of 6. Less than negative 2, so go to the left of negative 2. Number 17. Here we have an absolute value inequality, but we have to isolate the absolute value. We have to get rid of the 8. If you don't get rid of the 8, it's not going to turn out well. Absolute value of m minus 4 is less than or equal to 2. So this is not a greater greater. This is a less than, so it's an and. So m minus 4, this expression, has to be between negative 2 and positive 2. We keep the same sign, the less than or equal to sign there. Make sure it's equal to. So m minus 4 is between negative 2 and positive 2. Now solve by adding 4 to all three parts. So we get 2 is less than or equal to m is less than or equal to 6. And then graph 2 towards the left, 6 towards the right. They're both closed, and we want to be between them. It is an and, so we're looking for the overlap. We want to be between 2 and 6 for our solutions. All right, thanks for watching.